In this video, I'll be going over the key concepts from a lesson called Writing Equations to Model Relationships, Part 1, and the cooldown exit ticket called Shirt Colors. So this is where we first started writing equations to model relationships. So let's take a look at this together. Suppose your class is planning a trip to a museum. The cost of admission is $7 per person, and the cost of renting a bus for the day is $180. Notice that the number of students and teachers can vary. This means the cost of admission, the total cost of the trip can also vary because they depend on how many people are going. So the total cost depends on the number of people, the number of students, and the number of teachers. So if 24 students and 3 teachers are going, we know that the total cost will be 7 times 24 plus 7 times 3 plus 180, because remember, we've got this cost of renting a bus, and it's $7 per person, 24 students, 3 teachers. Another way we could write that is we could just come up with the total number of people, 24 students, 3 teachers, add those together first, and then multiply by 7. They're both fine. And then if we do it differently, if we have 30 students and 4 teachers, we would write it like that. Now, letters are helpful for representing quantities that vary. Since the number of students and teachers can vary, making the total cost vary, it might be more helpful for us to write a mathematical model like this. Our total cost is a variable, but it's equal to 7 times the total number of people, students and teachers, plus that fee for the bus. The 180 for the bus, we would call that a fixed cost. In terms of business, we would usually call that like overhead. So if you're running a business making skateboards, for example, there's certain costs that you have to pay for no matter how many skateboards you make. You have to buy your equipment, you have to pay for your building, those sorts of things. Materials all go into, those would be variable costs. But anyway, fixed cost, bus, and we can write our equation like this. So letters we can use to represent quantities that are constant. It's possible. It might be something that's not changing, but we don't necessarily know what it is. Sorry, tried to kill something. A bug. We can also use letters when something varies. So if the cost of the bus rental is $B, let's say we didn't know exactly how much the bus rental would cost, we could rewrite our equation as cost is equal to 7 times the total number of people, which is students and teachers combined, plus the cost of the bus, which we would call B. No matter how many teachers or students are going on the trip, $B. There should be a B. Need to be added to the cost of admission. All right, so let's take a look at the exit ticket cooldown thing. The school choir needs to make t-shirts for its 75 members and has set aside some money in their budget to pay for them. The members of the choir decided to order from a printing company that charges $3 per shirt plus a $50 fee for each color to be printed on the shirts. Write an equation that represents the relationship between the number of t-shirts ordered, the number of colors on the shirts, and the total cost of the order. If you use a variable, specify what it represents. So thinking about all of the stuff in the paragraph, how could we write an equation that would tell us the total cost for our t-shirts? Now, there might be some things that you don't know. There might be some things that you do know. There might be some things that maybe vary, that change depending on the situation. So if you don't know something, or if you think a quantity is going to possibly be changing, consider using a variable. And then after you write your equation, which quantities do you think can vary? Which might be fixed? If you have any questions about any of this, talk to me. Or if I'm not your teacher for some reason, talk to your teacher. I'm sure they'd love to help you out.